Hello viewers, in today's episode we will look at technology of milk products. When the milk is converted to milk products, there is a value addition to the product economically but also enhancement of nutritional aspects. There are a large number of dairy foods and dairy-based products in the market. The technology of some of the most popular dairy products is explained in the form of flow diagram. The products which are covered in this presentation are 1. Flavored milk preparation, 2. Dahi or curd preparation, 3. Yogurt, 4. Shrikhand, 5. Ice cream, 6. Chana and paneer, 7. Condensed milk and 8. Milk powder. Flavored milk preparation. Flavored milk, as the name indicates, is the milk which is flavored with natural or synthetic flavoring and natural coloring agents and sweetened with cane sugar. There are two types of flavored milk depending upon the heat treatment. They are A. Pasteurized flavored milk, which has low shelf life of 7 to 10 days in refrigerator temperature, and B. Sterilized flavored milk, which has shelf life of minimum 21 days at room temperature. The flow diagrams of flavored milk preparation is given in Figure 1. Figure 1. Flow diagram for pasteurized flavored milk. Reception of milk. Standardization of milk to desired fat and SNF. Clarification to remove invisible extraneous matter. Addition of sugar, that is 8 to 10% of the milk. Filtration to remove dust from the sugar. Preheating to 55 to 60 degrees centigrade. Homogenization 2500 psi in first stage and 500 psi in second stage. Final heating to 85 degrees centigrade for 15 minutes. Cooled to room temperature. Addition of color and flavoring agents. Mixed well. Filled to plastic pouches. Stored in cold room at less than 5 degrees centigrade. The milk for flavored milk preparation is generally standardized. The common synthetic flavorings used are banana, strawberry, mango, pista, almond and chocolate. Care should be taken to add corresponding coloring agents along with flavoring agents. If natural flavoring agents such as dry nuts, then they are to be ground to coarse texture and added to the milk after homogenization and before final heat treatment to avoid any contamination from the dry nuts. Figure 2. Flow diagram for preparation of sterilized flavored milk. Reception of milk. Standardization. Clarification. Addition of sugar. Filtration. Preheating to 55 to 60 degrees centigrade. Homogenization. Addition of color and flavoring agents. Filling into bottles in hot condition. Crown corking. Loading into retort sterilizer. Sterilization at 15 psi pressure for 15 minutes. Slow releasing of retort pressure. Unloading of retort, that is sterilizer. Natural cooling of bottles to room temperature. Store at room temperature. The sterilized milk has to be stored for at least 7 days before the bottles are released for sales. Dahi or curd preparation. Dahi or curd is fermented milk which is prepared by fermenting the heat-treated milk with lactose-fermenting lactic acid bacteria. During fermentation of milk, the milk turns sour due to production of lactic acid and this forms a firm gel. The lactic acid bacteria also produces secondary metabolites such as diacetyl, which gives typical dahi flavor to the product. The commonly used lactic cultures for dahi preparations are Lactococcus lactis, SPP lactis, Lactococcus lactis, SPP cremoris, Lactobacillus dibruxicil, SPP bulgaricus, and Streptococcus thermophilus. The flow diagram for preparation of dahi is given below in Figure 3. Figure 3. The flow diagram for preparation of dahi. Reception of milk, standardization, preheating to 55 to 60 degrees centigrade, homogenization, final heating to 85 to 90 degrees centigrade for 10 to 15 minutes, cooling to room temperature, addition of active lactic culture, that is 1% of the milk, mixing well to mix culture and milk, filling into pouches, incubation at 30 to 37 degrees centigrade for 8 to 10 hours. Check acidity before transferring to cold room. That is, desired acidity is 0.6 to 0.7% lactic acid. Transfer the pouches to cold room. Store for 8 to 10 hours to arrest the growth of lactic culture. Distribution. Care should be taken to avoid contamination of milk, particularly with yeast and molds at the time of mixing culture and packing, because the yeast and molds are main spoilage organisms in dahi as they grow well in acidic conditions. The optimum acidity in dahi is about 1.0%. However, it depends on the liking of the customer. Generally, the SNF content in milk is increased to about 10%. That is, normal SNF in milk is 8.5% during standardization of the milk to get dahi with better and firm body. Production of yogurt. Yogurt is also a fermented product similar to dahi. The body and texture and taste resemble dahi, but yogurt differs from dahi in terms of culture used for preparation and the flavoring compound released by the lactic acid bacteria. There are three main varieties of yogurt classified based on the mode of consumption. They are 1. Set yogurt, 2. Stirred yogurt, and 3. Drinking yogurt. Figure 4. The flow diagram for set yogurt is given below. Reception of milk, standardization of fat to about 3 to 4% and SNF to 10%. Addition of sugar, about 8 to 10% of the milk. Filtration, preheating to 55 to 60 degrees centigrade. Homogenization, final heat treatment 85 to 90 degrees centigrade for 10 to 15 minutes. Cool to 42 degrees centigrade. Add selective lactic culture, that is Streptococcus thermophilus and Lactobacillus delbrueckii, SPP bulgaricus at 4% of the milk. Fill into cups. Incubate at 42 to 43 degrees centigrade for 3.5 to 4 hours. Transfer the cups to the cold room. Store for overnight. Distribution. The yogurt is set for short period of 3.5 to 4 hours because addition of high amount of lactic culture, that is 4% of milk, and higher incubation temperature of 42 degrees centigrade. At the end of incubation period, the gel will be very soft and will not have any flavor except sour taste. The body becomes firmer and actual yogurt flavoring compound acetaldehyde is developed during storage in cold room. The stirred yogurt and drinking yogurt is also prepared in similar manner with slight deviation. The culture inoculated milk is incubated at 42 degrees centigrade in bulk and stored in cold room. Next day, fruit pieces and some stabilizers are added for preparation of stirred yogurt and for drinking yogurt. The yogurt is mixed into smooth consistency and filled into cups. For stirred fruit yogurt, 50% of sugar is added to milk during fermentation of milk. The fruits are cut into small pieces and mixed with remaining 50% along with 0.2% stabilizers and stored in refrigerator on the day of fermentation of milk. Next day, the bulk set yogurt and fruit sugar mixture is mixed well and filled into cups and stored in the cold room. Srikhand preparation. Srikhand is sweetened fermented milk product prepared from dahi. It has clean and delicate sour dahi flavor with the sweetness of sugar. Sometimes the product is flavored with natural flavoring agents such as cardamom and fruits like mango. When mango is used as flavoring agent, then the product is called as Amarkand. The whey from good quality dahi is drained by hanging in a muslin cloth to get semi-solid mass called chakka, to which sugar and flavorings are added to obtain Srikhand. The flow diagram for production of Srikhand is given below. Figure 5. Flow diagram for Srikhand preparation. Reception of milk. Separation of milk to skim milk and cream. Take skim milk. Heat treatment to 85 to 90 degrees centigrade for 10 to 15 minutes. Cool to room temperature. Addition of active lactic culture at 1% of milk. Incubation at 37 degrees centigrade for 10 to 12 hours. Dahi is obtained. Acidity 0.8 to 1.0 at lactic acid. Break the curd and transfer to muslin cloth. Hang the curd in cold room for overnight till all the whey is drained. Collect the semi-solid mass from muslin cloth. Chakka. Mix chakka, fermented cream, ground crystalline sugar and cardamom powder. Mix well. Kneading. Filling into clean cups. Storage at refrigerated temperature. Next, milk cream. Heat treatment to 85 to 90 degrees centigrade for 10 to 15 minutes. Cool to room temperature. Addition of active lactic culture at 1% of cream. Incubation at 37 degrees centigrade for 10 to 12 hours. Fermented cream. Transfer to cold room. Since the Srikhand is a sour product, the common spoilage microbes are yeast and molds. Hence, care is to be taken to minimize the yeast and molds during preparation of the product, particularly after fermentation of milk and cream. Ice cream production. Ice cream is defined as a frozen dairy product which contains a minimum of 10% milk fat, 3.5% proteins, max of 16% sugar, and 0.5% stabilizers and emulsifiers. It also contains incorporated air. The air is incorporated to get smoother body, insulating effect while eating, and to get desired overrun. Overrun is defined as the excess of volume of ice cream obtained over the initial volume of ice cream mix. Generally, 80 to 100% overrun is maintained in good quality commercial ice creams. According to FSSAI, there are 3 types of ice cream classified mainly on the fat content. That is, low-fat ice cream with less than 2.5% fat, medium-fat ice cream with fat content varying between 2.5 and 10%, and normal ice cream with fat content of more than 10% fat. It is rich in fat and carbohydrates. The most important equipments required for the production of ice cream are homogenizer, ice cream freezer and deep freezer maintained at around minus 25 degrees centigrade, in addition to other facilities like heating system, vats for mixing the ingredients, and aging vats. The flow diagram in Figure 5 for production of ice cream is given below. Figure 5 flow diagram. Reception of ingredients. Formulation of ice cream mix. Mixing of ingredients. Heat treatment to about 60 degrees centigrade. Homogenization, 2 stages. 2000 psi in first stage and 500 psi in the second stage. Pasteurization. Batch type 75 degree centigrade, 15 minutes. Type 85 degree centigrade, 15 minutes. Cooling to 5 degrees centigrade. Aging at 5 degrees centigrade for a minimum of 6 to 8 hours. Mixing of color and flavor. Freezing in ice cream freezer. Incorporation of air. Drawing into unit packages. Storing in hardening cabinets. Hardening at 25 degrees centigrade for at least 24 hours. Distribution. Common sources of ingredients: fat, cream, butter, whole milk and whole milk powder, milk SNF, milk, cream, skim milk powder, whole milk powder, condensed milks. Sugar: cane sugar, beet sugar, liquid glucose, corn syrups. Stabilizers: sodium alginate, guar, gum, pectin, carrageenan, locust bean gum, and carboxyl methyl cellulose. Emulsifiers: glycerol monostearate, lecithin, and sometimes egg solids. Flavors: synthetic and natural flavoring agents, nuts and fruits. Reception of ingredients. Always good quality raw materials should be received, and they have to be tested for the freshness and chemical composition. If any off flavor is present in any one ingredient, it will reflect in the final product. Formulation: ice cream mix should contain a minimum of 10% fat, 3.5% milk protein, maximum of 16% sugar, and maximum of 0.5% stabilizers and emulsifiers. In order to obtain the ice cream mix with desired composition, it is necessary to work out the quantity of each ingredient in the mix. This is worked out by using formulae. Mixing of ingredients. The dry and wet ingredients are mixed separately. Then the mixture of dry ingredients is mixed slowly into liquid ingredients. This method is followed to avoid any lump formation during mixing of ingredients. If lumps are formed during mixing, particularly the stabilizers and emulsifiers, then it will be very difficult to further process the mix. Preheating of mix to around 60 degrees centigrade. Heating of mix to around 60 degrees centigrade helps in bringing all the soluble solids into solution form and makes a homogeneous mix to facilitate homogenization. This is also necessary to inactivate a native enzyme called lipase, which breaks down the fat to fatty acids and results in development of undesirable off flavor. Heating of mix to about 60 degrees centigrade inactivates the enzyme and thus safeguards the product from development of off flavor. Homogenization. Homogenization is the process wherein the bigger fat globules are broken down so that the fat does not rise to the top during aging period and do not churn out into butter granules during freezing process. It is a high-pressure operating equipment wherein the product is pumped through a very narrow passage such that the fat globules, which are bigger than the passage, are broken down to smaller sized globules. Once the fat is broken to smaller size, they lose the tendency to separate out from the mix and do not get churned out into butter granules during the freezing process. Pasteurization. This is the process of heating the mix to about 75 degrees centigrade for 30 minutes or to 85 degrees centigrade for 16 seconds and then immediately cooling to 5 degrees centigrade. The main purpose of pasteurization is to render the ice cream safe for consumption by eliminating the pathogenic organisms, bring all the ingredients into the homogeneous liquid, improve the flavor of the ice cream, and improve the shelf life of the product. After heating the mix to the desired temperature time combination, the mix is promptly cooled to less than 5 degrees centigrade and stored at that temperature for aging. Aging. Aging is the time of holding the mix at 5 degrees centigrade for a specific time. Generally, it will be 4 to 6 hours. The aging period depends on the kind of stabilizer used in the ice cream mix. Sometimes ice cream mix will be kept overnight for aging. The main objectives of aging are: A. To allow the stabilizer to swell and bind the free water. B. To reduce the size of the ice crystals in ice cream. And C. To facilitate in increasing the overrun. Addition of color and flavor. The mix that is prepared by above method is the base mix, which is common for all varieties of ice creams. The actual variety of ice cream depends on the type of color and flavor that is added to the mix before freezing. The desired color and flavor are added to the mix after taking out from the aging vat. In batch-type freezer, the ice cream mix takes about 6 to 8 minutes to get converted into semi-solid mass. In continuous type freezer, it takes about 25 minutes. Once the mix is transformed into semi-solid condition due to freezing, air is incorporated into the semi-solid ice cream mix. A good quality of ice cream will have an overrun of about 80 to 100%. It means that the 100 ml of ice cream will contain 40 to 50 ml of air and remaining will be the ice cream mix. Packaging and storage of ice cream. The ice cream, after incorporation of air and obtaining desired overrun, is drawn to packaging material directly before they are stored in hardening chambers for hardening of ice cream. Generally, ice cream is packed into 50 ml, 100 ml, cups of 500 ml and 1000 ml family packs and 4 liters of party packs. The ice cream is stored for a minimum period of 24 hours at hardening temperature of -25 degrees centigrade. This is to facilitate conversion of soft ice cream to hard ice cream. Paneer preparation. Paneer is heat and acid coagulated product. It is prepared by heating the milk to 85 degrees centigrade and then coagulated with edible acids such as citric acid, lactic acid, and acetic acid. The coagulated mass is separated from whey by filtering through muslin cloth. The coagulated mass is then pressed and dipped in chilled water to obtain paneer. Paneer is used in various kinds of curries such as paneer butter masala, palak paneer, paneer matar masala, etc. Figure 8. Flow chart for production of paneer. Reception of milk. Filtration. Standardization. 5.0% fat, 8.5% SNF. Heated to 85 degrees centigrade. Cooled to around 75 degrees centigrade. Addition of citric acid solution. 2% citric acid solution heated to around 70 degrees centigrade. Allowed to settle for 5 minutes. Transfer to muslin cloth. Transferring the mass to mold along with the cloth. Pressed for about 30 minutes. Removing the pressed mass from the muslin cloth. Transfer to chilled water, kept for about 30 minutes. Paneer. Cut to desired size. Packaged and stored at refrigerated condition. Paneer, when prepared under hygienic conditions and stored under refrigeration, can retain quality up to 5 to 7 days. Vacuum packaging increases the shelf life by another 1 week under similar conditions of storage. Chena. Chena is also a heat and acid coagulated milk product. The procedure for production of chena is almost similar to paneer production with following modifications. The milk is heated to 80 degrees centigrade and cooled to 70 degrees centigrade before it is coagulated with citric acid solution. After coagulation, it is transferred to muslin cloth and hanged at room temperature for drainage of whey. But in paneer, the coagulum is pressed with mechanical pressure to get compact body. The chena is soft with loose texture, while paneer is compact and firm. Chena is used in preparations of sweets such as rasagolla, rasamalai, sandesh, and other Bengali sweets, while the paneer is used in preparation of curries. Condensed milk production. Condensed milk is a product obtained from milk by partial evaporation of water under vacuum. The plain concentrated milk is called evaporated milk and it is preserved by sterilization. If the concentrated milk is sweetened with sugar, it is called condensed milk or sweetened condensed milk. The sweetened condensed milk is preserved by addition of high amount of sugar, which serves as natural preservative. The ratio of concentration of milk solids is about 1:2.5 for whole milk and 1:3 for sweetened condensed skim milk. The flow diagram for production of sweetened condensed milk in Figure 10, which is given below. Figure 10. The flow diagram for production of sweetened condensed milk. Reception of milk. Filtration. Clarification. Standardization. 4% fat, 9% SNF. Reception of crystalline sugar. 18 to 20% of milk. Preheat to 115 to 118 degrees centigrade. No hold. Addition of water to make about 65% sugar syrup. Drawing into vacuum pan at 700 to 720 mm mercury height. Condensation of milk to about 1:2.5 ratio of total solids. Drawing of sugar syrup into vacuum pan, condensation continued till total solids reaches 74%. Cooling tank. Slow cooling to 30 degrees centigrade. Seeding of condensed milk with lactose, 0.2 to 0.3% of condensed milk. Vigorous agitation and slow cooling, 12 to 15 degrees centigrade. Agitation and till packaging. The sugar content in final product will be in the range of 42.5 to 45%. This high level of sugar gives preservative effect to the product at room temperature. Since lactose is condensed milk is supersaturated level, seeding of condensed milk with powdered lactose is done to avoid formation of large lactose crystals, which is objectionable. Production of milk powder. The excess milk is separated into cream and skim milk. The cream is converted into butter and skim is converted into skim milk powder to conserve the milk solids. The butter and skim powder are used in various food formulations. When whole milk with fat is dried, it is called whole milk powder. When skim milk is converted to powder, it is called skim milk powder. In our country, most of the milk powder produced is skim milk powder. The flow diagram of production of skim milk powder is given below. Figure 11. Flow diagram of skim milk powder. Reception of milk. Warmed to about 40 degrees centigrade. Separation. Cream to butter. Skim milk. Preheating milk to 115 to 118 degrees centigrade. Condensed under vacuum multi-stage evaporator. Condensed to about 40 to 45% total solids. Cooling of condensed milk to 5 degrees centigrade. Transfer of condensed milk to storage tank. Warmed to about 55 degrees centigrade. Drawn into balance tank. Pumping into drying chamber through atomizer. Inlet temperature at 180 to 200 degrees centigrade and outlet temperature 90 to 95 degrees centigrade. Collection of fine milk powder. Revetting with steam to about 10 to 12% moisture. Agglomeration. Fluidized bed dryer to remove added water. Coarse skim milk powder. Drawing from drying chamber. Transfer to powder silos. Packaging. The milk should be tested for alcohol test to check its stability for higher temperature of 115 to 120 degrees centigrade. For production of whole milk powder, the process is same with slight modification. They are: the milk is homogenized since it contains milk fat. The milk powder is packed in inert gas packing to avoid fat oxidation. Lecitination of fat globules is essential to give emulsification effect. Friends, with this, we have come to the end of today's episode. We hope that you have a good time learning. Until next time, goodbye.